In this video, I will explain how to write numbers with the correct amount of significant figures after performing multiplication or division. So I have 4 practice problems for us to work through here. We're going to perform either multiplication or division, and we're going to write the answer with the correct amount of significant figures. Now I've gone ahead and listed out the 6 rules for determining whether or not digits are significant figures or not. So we can reference these rules as we work through these problems. Now, when we're doing these problems, here's what we need to know. The number with the least sig figs is how many sig figs the final answer should have. So when we're doing these types of problems, we're just going to perform the math like normal, and then afterwards we'll round to the correct number of significant figures. Okay, so let's jump into some practice problems. Let's check out number 1 here. We have 0.0036 times 0.02. Now, the first thing we want to do is determine how many significant figures are in each of these numbers. So for 0.0036, these leading zeros are not significant. And we can reference rule number 5 over here to verify that. Leading zeros in any number are not significant. But the 3 and the 6, these are significant figures. And we can reference rule number 1 to verify that. All non-zero digits, so digits between 1 and 9, are significant. So this first value has 2 significant figures. So let's go ahead and write 2SF above that, significant figures. Now for this second value, 0.02, again, the leading zero is not significant, but this 2 is significant. So this value only has 1 significant figure. So let's write that, 1SF. So our final answer, we're only going to have 1 significant figure. So we always choose the lesser significant figures between the 2. So if you just punch this into a calculator, 0.0036 times 0.02, here's what you get. So we get 0.000072. Now, right now, this result has 2 significant figures, the 7 and the 2. But remember, we only want to write it with 1 significant figure. So what we're going to do is identify the first significant figure, so that would be the 7. Then we'll look at the number that comes after it, and we'll see, should we round the 7 up, or should we just keep it as a 7? So if this number right here is a 5 or greater, we would round this 7 up to an 8. But since this is less than 5, we just keep it as a 7. So our final answer we're going to write as 0.00007. So this is our final answer, and this only has 1 significant figure, the 7 right here, which is what we wanted. Okay, now let's check out example number 2. 3.08 times 5.2. So again, the first step is identify how many significant figures are in each of these numbers. So in this first number here, we know the 3 and the 8 are significant because they're non-zero, and this 0 right here in between them is also significant. And we can reference rule number 2 over here to verify that. Zeros between non-zero digits are significant. So since this 0 is between 2 non-zero digits, it is significant. So this value, 3.08, all 3 of these digits are significant. So let's write 3 significant figures. Then for the 5.2, both the 5 and the 2 are significant, so that has 2 significant figures. So let's write 2SF. So in our final answer, we're going to make sure that our final answer only has 2 significant figures. So if you punch this into a calculator, 3.08 times 5.2, here's what you get. So we get 16.016. But remember, we want to round this to only 2 significant figures. So the first 2 significant figures in this number are the 1 and the 6. So we'll look at the second significant figure, and then we'll take a look at the number that comes after it. And this will tell us, do we round up the 6 to a 7, or do we keep it as a 6? Well, since this is a 0, we're not going to round up. We're going to keep this as a 6. So our final answer is just going to be 16. So notice this answer has 2 significant figures. All right, now let's check out example number 3. 7.895 divided by 34. So again, let's identify how many significant figures are in each of these numbers. So in this first number, all 4 digits are significant. So let's write 4SF. And in this second number, the 3 and the 4 are both significant, so this has 2 significant figures. So the lesser of these 2 values is the 2. So our final answer should only have 2 significant figures. So if you punch this into a calculator, here's what you get. So we get this long decimal here. And remember, we only want to write this answer with 2 significant figures. So the first 2 significant figures in this number are the 2 and the 3. So if we take a look at the second significant figure and analyze the number that comes after it, this 2 tells us we don't need to round this 3 up to a 4. We can keep it as a 3. So our final answer is just going to be 0.23. And this answer has 2 significant figures. Okay, now let's check out our last example here. We have 1.001 divided by 1.25. So once again, we're going to identify how many significant figures are in both of these numbers. So in this first value, the 1 and the 1, those are both significant figures, and the zeros are wedged in between two non-zero digits. So both of these zeros are also significant figures. So this number has 4 significant figures. So let's write that. 4 SF. And in this second number, the 1, the 2, and the 5 are all significant. So this has 3 significant figures. So our final answer is only going to have 3 significant figures. So if you punch this into a calculator, here's what you get. We get 0.8008. And remember, we only want to write this with 3 significant figures. So the first 3 significant figures in this number are the 8, the 0, and the 0. So if we take a look at the third significant figure and then analyze the number that comes after it, this 8 tells us to round up the 0 to a 1. So our final answer is going to be 0.801. And this answer has 3 significant figures. So those were just 4 quick examples of how to write numbers with the correct amount of significant figures after a multiplication or division problem.